All right, so today we have linear functions and slope-intercept form. All right, so linear has the word line in it. So if you have something that's linear, that means you're going to make a line. All right, we've got horizontal lines, we've got vertical lines, we've got lines that as you go left to right, they go up, and lines that as we go left to right, they go down. Okay? All right, so these are your four basic lines that you can have. All right, now let's talk about slope. These four lines that I drew, they lean differently. Okay, so this one is flat. Okay, it's horizontal. This one is straight up and down, it's vertical. I said as we go from left to right, this one goes up. As we go from left to right, this one goes down. So when you're thinking about this, let's think of a roller coaster. All right, first of all, when we read anything, we go from left to right. So everything that I'm doing is going to go left to right. So as we go from left to right on this horizontal one, okay, pretend like you're on a roller coaster. All right, so we've got this little car, and I always think of Mr. Brogan. I used to teach with Mr. Brogan at the middle school. All right, got this little person in here. Uh-oh, lost my car. Okay, all right, so we're on a roller coaster. This was always Mr. Brogan's favorite type of roller coaster because how fast is it going to go if it's completely flat? It's not going to go. If you put him in here and there's nothing pulling it, okay, he's just going to sit there. It's not going to travel anywhere. Well, its slope happens to be 0. He doesn't travel anywhere. Okay, this one, if we put Mr. Brogan, he would be so happy that I'm talking about him. I'll have to tell him sometime. I'll go back to my vertical line. I have to be quicker than that so I don't erase it again. All right, so we've got Mr. Brogan here, got some circles for his wheels, got him up here. All right, so if he is on this roller coaster that's completely straight up and down, unless he's got some hooks on that, he's going to fall off of this roller coaster. All right, now it's kind of morbid here, but the way that it might actually help you remember this is, so this one straight up and down, that's not going to work. That is not going to work. So we call that slope undefined. Haven't got to the morbid part yet. Give me just a second. Undefined. All right. Well, straight up and down, vertical, that slope is undefined. And you can think of it this way. If Mr. Brogan is on this roller coaster and there's nothing holding him onto these rails, he's just sitting on the rails, he's going to fall off and die. All right, yes, I did say that. All right, so here is the way you can remember this. Undefined, we don't want that. All right. He's going to fall off and die. All right. So, and this is not actually my story. This is Mr. Brogan's story. All right, he made this up. I can't take credit for this one. All right, now, if he is on this roller coaster, all right, here he is. Well, he's down here at the bottom. He's going to have to go up the roller coaster. All right, so he's going up. When we think about going up, well, that slope is positive because as you go left to right, you're going up, which he's okay with that part too. This is the part that he does not like. If Mr. Brogan is on this roller coaster and we go left to right, he's going down. And that is the part he does not like. So when we think of going up, we think positive. When we think of going down, we think negative. All right, so those are the basics of slope and how your line leans. If it's flat, the slope will end up being 0, and I'll show you why in a minute, according to the formula. If it's vertical, it's called undefined. If we're going from left to right, we're going up, it's positive. You're going down, it's negative. So those are some basics. Now, mathematically, how it works is this right here is the formula for slope. All right. So slope describes how much and in which direction you're leaning, okay? So as we go left to right, if we're going up, that's positive. And the steeper the hill, the higher the number. The flatter the hill, the lower the number, okay? All right. So like the flat, that slope is 0. As soon as you go up a little bit, give it any kind of a ramp, that number will get bigger than 0. All right, so here we go. If that is the equation for slope, all right, let's say we have 2 points. Okay, if we've got a flat line here, this point right here and this point right here. Well, if you're looking at those 2 points, what we know about them, since they are side by side, we know that their y has to be the same. All right, so I'm just going to make up 1, 2. So let's say this is the point 1, 2. So we were down here, we went over 1 and up 2. Well, we must be going over farther, let's say 5, but we're still going up 2. Okay, so if you're thinking about a coordinate, all right, let's say down here is your origin. If you go to the right 1 and up 2, you're there. You go to the right 5 and up 2, you're there. It makes a flat line. So if you do that formula for that, it's called rise over run. Okay, so you subtract your y values. So if we subtract our y values, we'll have 2 minus 2. If we subtract our x values, whether you want to go 1 minus 5 or 5 minus 1, it doesn't matter on this one because these are the same. You're going to get 0 over 4, which is just 0. Okay, even if I would have gone 1 minus 5 on this problem, you would have gotten a negative 4. It's still 0. Okay, because the y values were the same. All right, so let's get rid of some of this stuff. All right, so kind of going back to that. We've established that if it's a flat line, your y is going to be the same. I'm worried that some of you may be having trouble with that. So we will make some notches here on the graph. That maybe that will help you a little bit. All right, so if I want to go from this point right here to this point right there. To get there, it's always rise over run. Well, I'm not rising at all. I'm not going up or down, so that's why it's a 0 on top. And I'm running 1, 2, 3 in the positive direction. So that's why the slope is 0. It's a flat line. All right, so let's do another one. Let's talk about that vertical line. All right, if I've got a point maybe right here and a point right here. All right, those are my 2 points straight up and down from each other. All right, if I want to do the rise over run, and it's called rise over run because you're subtracting your y coordinates. Your y coordinates tell you how far you're going up or down, and the x coordinates on the bottom tell how far you're going left or right. All right, so if I'm going up, if I start from this point here, I'm going to rise 2 places, and I'm not going to go side to side, so I'm running 0. If you type in your calculator 2 divided by 0, it doesn't work. You cannot divide by 0. Okay, it's like saying, hey, I've got 2 pieces of candy. I want to divide it into 0 groups. Well, as soon as you have anything, you already have at least 1 group of it. So it is impossible to divide by 0. You can never have 0 on the bottom. Okay, it's undefined. So that's why a vertical line is undefined. Remember the fall off and die thing. All right, then we've got positive and negative slopes. So if let's say I'm starting there at 1, 1, and I'm going to go up here to 4, 2. All right, if you're going to do that, you're going to rise. So I'm rising, I'm going up 1, so that's a positive 1. And then I'm running positive 3, went to the right 3. This is a positive slope. So this line right here, from this point to that point, you're going up positive and to the right, so that's another positive. So that's why you're going to get a positive slope when it looks like this. As you go left to right, it goes up, it's positive. Notice that is 1/3, okay? It's pretty flat, all right? If we did something else, if I started down here and going up here, I would be rising a positive 3 and go up positive 3 and then to the right 1, so that's a positive 1. That gives me a slope of 3. Okay, this line is steeper than the other one, so its number part is bigger, all right, because it's steeper. Still, as I go from left to right, I'm going up, so I got a positive slope. But notice that's a lot steeper than this other one, and the number reflects that, okay? All right, then we could talk about the negative slope real quick. All right, if we were up here and we were going down here, all right, so our line is doing this. Well, we would be rising 1, 2. So now when I say rising, but which way are we going? We're not going up, we're going down. So if you're going down, that is actually a rise of -2, because we're going down 2. Then we're going to run a positive direction 2 places. It's not going to let me write right there. That's going to give us a -1. That's what that's going to give us. It won't let me go over that far. All right, so my point here was, if you're going this direction, we went down, so that's negative, and then to the right, that's positive. That gives us a negative answer, okay? So that's going down, you get the negative slope. All right, so that's a lot of information there. Some of you probably had it right off the bat, but if you didn't, I want to make sure that you're clear on that. All right, then we have slope-intercept form. Slope-intercept form is a nice way to know that something is a line. This is slope-intercept form. If you get y by itself, you have some big equation, you get y by itself. And on the other side, you've got an x term and maybe something else, like a number over here, then you don't have to make an xy table to graph that line. You start out here, this right here, that's your y-intercept. Y-intercept is where the line hits the y-axis, okay? And then this is your slope. So the way that works, let's pretend like we have y equals 1/2 x plus 3. All right, you always start with your y-intercept. Another way to think of that is you start, instead of start, this is where you begin. You begin here where the letter B is, B for begin. So if you were going to graph that without having to make the XY table, put a few more dashes on here. All right, so you would begin at the y-intercept, which is 3. Well, this is the y-axis, so we will intercept, which sounds like intersect, at 3. Then from that point, we're going to do our rise over run. So we're going to rise a +1, that means go up, and then run a +2, so that puts us over here at that point. And then you would draw your line. So if you have to graph this, that's how you graph it. You begin at the y-intercept, put your point down, and from that point you do this slope. Rise and run. All right. So write each, this is page 78, write each equation in slope-intercept form. All right, slope-intercept form looks like this. So basically, we want to get y by itself. That is our goal. So our goal is to get that y by itself. All right, to get the y by itself, we have to get rid of the x, the 2, and the 3. The x and the 3 are both about the same distance apart, or same distance from the y. They're both farther away. It doesn't matter which one you get rid of first. I'll get rid of the x. This is a 1x right there. It's a positive, so I'm going to subtract it to get rid of it. So I have to come up to the right side and do the same thing. So that leaves me a negative 2y plus 3 equals. Now, when you rewrite this, be careful. Since I know that this x term in this formula I'm looking for, I know the x term comes first, and then I'm going to have a number back here. So because I know that, I'm going to go ahead and put the x term first. And then this is a positive one, so I'm going to put it behind it. Because you're going to have an x term and then a number. All right, so we're still trying to get the y by itself. I need to get rid of the negative 2 and the 3. 3 is farther away. It's being added, so I will subtract. When you go over to the right side to subtract the 3, line it up. Does the 3 go with the x term or the number? Well, it goes with the plus 1. That's what you can actually put it with. So the 3's go away. You have negative 2y equals, bring down the negative 1x, and 1 minus 3 is a negative 2. Y is still not by itself. We need to get rid of the negative 2 that's being multiplied. So we divide the left side by negative 2 and the right side by negative 2. So we have y equals. Now, this next part is distributive property. Distributive property is not just with multiplication, it's also with division. So each term that we have up here can be divided by the denominator. So we're going to take the negative 1x and divide it by the negative 2. So we're going to take the negative 1x, divide it by negative 2, and then we'll take this over here, negative 2 divided by negative 2. I'm just going to put a little plus in between there, just like we have over here in our equation. Let's clean it up. Negative 1 divided by negative 2, and negative divided by negative ends up a positive, and we're going to leave it 1/2. Now, the x. If I have this, 1/2 times x. If I was multiplying those two, I'd have to put x over 1 to be able to multiply. And if you did it, you would get a 1x over 2 times 1 is 2. So what I'm trying to show you is this right here can just be written x. These two things are the same. So when you have an x on top, okay, you've got this fraction with numbers, and you just have this x, especially in slope-intercept form, you can actually just put it behind. Make sure you realize, just like you have the number 5, that's really you see the number 5? Well, it's really on top of a fraction. It's over 1. All right, same way this is. If that x is on top, you could also write it out behind it, because it really means over 1. So I know it's a lot of stuff to say, but in this problem right here, take the numbers and reduce them, and then the x we'll just put behind. And then a negative over negative becomes positive, and 2 divided by 2 is 1. So this would be your equation for number 1. All right, so your goal is to get y by itself, so you have to get rid of everything with it, get rid of things that are being added or subtracted first, and then you'll get rid of whatever is being multiplied or divided. All right, we're going to go to number 2. All right, so number 2, draw my line. We're trying to get y by itself because we want it to look like this. That is slope-intercept form, the y by itself. So we have to get rid of the 3 and the minus 4x. We get rid of this first. Since it's subtracting 4x, we're going to add 4x to both sides. Okay, so that's going to go away, leaving us 3y equals. Now, which term should I write first? The positive 1 or the positive 4x? We always want that x term to be first. So we could put the 4x and then the plus 1 behind it. You cannot put those together. They are not like terms. They don't have the same lettering. All right, so to get y by itself, I need to divide by 3 on both sides. So everything on the right gets divided by 3. So 4 over 3 doesn't work out nice. So we leave it as a fraction. And the x we'll just put back here behind it. And then we're going to have plus the 1 over 3. Okay, so that's the equation in slope-intercept form. All right, so now what is the slope of a line passing through the following points? So now we're going to find the slope using the formula. Now, you could go and draw a graph and do the rise over run, but I'm going to use the formula this time. This is the formula. What it says basically is that we are starting from one point. We're going to call that point 2. All right, that's a subscript. It's not a square. All right, it's saying, hey, this is from point number 2. And then this little 1 means that these two coordinates are from point number 1. So you have to first decide which one is point 1 and which one is point 2. And usually people make the first one 1 and the second one 2. All right, so if that's the case, that's fine. If you get confused doing this, you might want to label them underneath. See if I can make it really small. So if this is my point 1, that would be in x1. That's my x coordinate, and this is my y coordinate with a little 1 there. This is my x coordinate, but it's a second point. This is my y coordinate, and it's a second point. Maybe. Oh my. Try that again. Okay, there we go. All right, so if you get confused here, just label them, all right? So then whenever you get ready to do your formula, this is how I set it up every time. I always go ahead and put the minus in there, all right? So this is where my y2 goes, which is 2. And then my y1 is going to go right here, which is 4. Then here's my x2 number, which is 4. And my x1 number is 2. And then you work it out. 2 minus 4 is a negative 2. 4 minus 2 is a positive 2. Negative 2 divided by 2 is a negative 1. So the slope is 1. Or sorry, negative 1. That would be your answer. All right. So that's the way some people do it. They go ahead and just label them and then just plug it in. Other people know that I'm going to have my y is being subtracted on the top. But what you need to realize is, like, this was y2. It came from here. And that was y1. It came from there, right? So we went y2 minus y1. On the bottom, we started with that second point again. So this was the point we started with on both of these, right? We started with that second point both times. That's the important part. It doesn't matter which point you start with, but you have to start with the same point up here and down here. So if you want to do this, okay, if you're just dealing with your y's, I'm going to take the 1 minus the negative 3. So I went that direction. So I'm going to put the 1 here. This right here is why I always put the minuses in at the beginning. Put the 1 down. Now I'm going to take this -3 and plug it into this empty spot. If you don't put the minuses down, you'll have a tendency to go 1, and then you're already thinking minus, but you've just put -3. So be careful and not put 1 minus 3. Okay, so that's why I always put those minuses, the subtractions, in at the beginning. All right, so again, we're starting from 1, and we're subtracting the -3, so we just subtracted our y's on top, and then our x's, you have to start from the same point and go in the same direction, and they'll go on the bottom. So notice I did my arrow up here on top for my y's and down here on the bottom for my x's. So since I started with this point, 3, 1, I have to start with it again down here. So my x goes there, and my -1 goes there. All right, when we are subtracting a negative, it's the same thing as adding a positive. You end up getting 4 on the top. Subtracting a negative, same as adding a positive. You get a 4 on the bottom, and you get a slope of 1 on that one. Now, if you're afraid that you'll get the x's and y's mixed up, forget which one to start with, the arrows don't really work for you, then come back over here and do like I did on this one. All right, label them x1, y1, x2, y2, and then follow this formula. All right, so a little review here. What is a y-intercept, and how does it differ? How is it different from an x-intercept? All right, so let's talk about that real quick. Here's your x-axis and here's your y-axis. All right, if we have a line going through here, all right, got a line. This point right here, whatever that number is, that is where this line is hitting your x-axis. So that number is your x-intercept. So the x-intercept is the point at which the graph hits the x-axis. Okay? Then the point where the graph hits the y-axis would be your y-intercept. Okay? You could use the word intersect if you want to. All right? The word intersect looks like this. It is very similar to this word. All right? It has like 2 letters that are different right there. Enter, and then the S and the C are just different right there. All right, so that's the difference between a y-intercept and an x-intercept. Number 6, explain why the slope of a vertical line is called undefined. All right. It's called undefined because when you have a vertical line, okay, when you're finding the slope of a vertical line, the rise is on top, the run is on the bottom. All right. So when you have a vertical line and you got 2 points here, all right, you go from one point to the other, you're going to have a number here. You're going to have some number on top where you have risen, you've gone up, but you're not running. So you're running 0 units. You cannot have a 0 on the bottom. We cannot do it, and that's why it's called undefined. You can't have a 0 on the bottom of a fraction. And then number 7, classmate found the slope between 2 points. What error did she make? All right, so we've got the first point, our x1 is 3. Our y-coordinate from that same point is 4. Our x2, so our x-coordinate from our second point is 2. And our y2, that's our y-coordinate from our second point, is 7. All right, so let's go back to the formula. It's y2 minus y1 over x2 minus x1. Okay, so according to our formula and the way we've labeled it, this would be y2, that'd be a 7, minus the The y1 would be a 4. And then the x2 would be a 2. And the x1 would be a 3. This is one way to do it, okay? If someone decided to label them backwards, okay, if someone decided to make this one my second point, and this one my first point, then their slope problem should look like this. They would put their y2, which now we're making this one our second point up here. Okay, if this is our second point, then that's our y2, and our y1 would be down here, and then our x2 would be the 3, and our x1 would be the 2. All right. What I want you to notice, either way you want to do it, doesn't matter which point you label first or second. Okay, that's a big deal here. But if you look at this, see how this was 7, then the 4, and this is 4 and 7, it's backwards? Well, so is the bottom. Okay, so like if you go ahead and work this top one out, you're going to get 7 minus 4 is 3, and this down here is -1, and we get a -3. If you labeled them the other way, different points, 4 minus 7 is a -3, and 3 minus 2 is 1. It's still a -3, but notice how the numbers are the same. We still have a 3 on the top and a 1 on the bottom, just the signs are backwards, but you still get the same answer. All right, so you got to figure out, what did she do wrong? She has a 4 minus 7, which looks like this one, right? 4 minus 7, but then the bottom is a 2 minus 3, and that looks like this one. So she started with, on the top, she started with this point. She started with the 4 and went to the 7. On the bottom, she started with the second point and went backwards. So that was her mistake. You can just say that she started with one point on the top and it started with the other point on the bottom. Okay, got her X's and Y's mixed up, however you want to put it. All right, so that is it for today. That was a long session. A lot of information there.